Hello, students. We are continuing with the quadratic equation part 4. We are taking up some very important questions right from your textbook. We have done lots of methods for solving the quadratic equation. We have done three methods. We have known what will be the nature of the roots based on the discriminant value, that is the value of b square minus 4ac. And then we have done a little bit of a deduction also. Okay, so I'm taking up some very important questions from your textbook from exercise 5.1 from your textbook. Okay, here is a question number 7. Most of the questions above question number 7 we have already done as examples when I explain each topic. So I believe you can solve them very easily above question number 7. So question number 7, here it is given alpha beta are the roots of the equation x square minus bx plus q equal to 0. Find the values of, you have to calculate the values of alpha plus 1, beta plus 1 whole. And then this is from Roman number 2. Roman number 5, this is alpha square by beta plus beta square by alpha. Okay, this one is a little bit easy. This is also easy, but it will be a little bit longer. Okay, let's see. First of all, let's see what this will produce. All right. So here, let's do on the side, just for the sake of seeing what does the question want us to do. Alpha plus 1 whole bracket, beta plus 1 whole bracket. So when you open the bracket, do distributive property alpha into beta, it will be beta, alpha beta. Alpha into 1, it will be alpha. Likewise, do multiplication by 1 like this. So first term will be alpha into beta, alpha beta. Next term will be alpha plus 1 will be alpha. Plus 1 into beta will be beta. Plus 1 into 1 will be 1. Here you can see we have 4 terms. 1, 2, 3, 4. What if I put these two together? Alpha beta plus beta plus 1. What is this? This is the product of roots, right? Product of roots. We know that according to the equation, alpha beta are the roots. Product of roots, it's very easy. We can find it out by using C by A. We just have to determine what is C and A from the equation. Alpha plus beta, this is the sum of the roots. So we can find this out by using minus B by A also, right? So very simple and easy. Let's do the first Roman number. Okay, that means from here, we need the product of the roots and the sum of the roots. We will need for this question also and for this question also. Okay, so first of all, we need to find out what is A, B, and C from this equation right here. And then we will find out the sum of the roots and the product of the roots. So here, solution. Okay, this part is common for both equation. From the equation, x squared plus bx plus q is equal to 0. What is A? A is 1. B is what? B is p. C is q. What is the sum of roots now? Sum of roots will be represented by alpha plus beta, since alpha and beta are the roots as given by the equation. This will be minus b by a. Put in the values already. Minus b is p, a is 1, so we get minus p. What about the product of the roots? Product of the roots, that will be alpha into beta, alpha beta. This is c by a. Put in the values, so we get q by 1. This is q. Very easy, right? Now let's find out the Roman number 2. Roman number 2, it's alpha plus 1 whole bracket, beta plus 1 whole bracket. Okay, we have done multiplication already, right in the introduction. So when you multiply, you are obtaining alpha beta plus beta plus 1. What's the value of alpha beta? Here it is. So we will replace it by q plus, what about alpha plus beta? Alpha plus beta is here, this value right here. So since there is a minus sign, we will put it inside bracket, plus 1. Okay, now open the bracket, plus minus is minus, so q plus minus is minus, plus 1. This is the value for alpha plus 1 whole bracket, beta plus 1 whole bracket. All right. Okay, let's do for Roman number 5. Roman number 5 will be slightly longer. Still very easy if you are able to remember all the algebraic formulas. right? A plus b whole square is this, a minus b whole square is this, a plus b whole, a minus b whole is this value, and then alpha a plus b whole cube, a cube plus b cube, a cube minus b cube. Those formulas that you have already learned in class 9. You just have to remember this, clean your concepts, read a little bit for class 9 and this algebraic these algebraic problems like the ones that you have faced in factorization here also, they will be very easy. Okay, let me rub this and let's come to Roman number 5. Roman number 5, we are given alpha square by beta plus beta square by alpha. Okay, let's do addition of these two terms. First of all, you have to multiply the two denominator, beta and alpha. So what are we going to get if you do a little bit of addition? Denominator will be alpha beta. And then now you do cross multiply. Alpha and alpha square. Alpha into alpha square. There is a square here. There is a power here. You add the power. It will be alpha cube plus. Same thing here. Beta multiply with beta square. We are getting beta cube. We know the value of this one, right? Alpha beta we already have here. Alpha beta is cube. But we don't know the value of this one. Alpha cube plus beta cube. Okay, you know there is two ways in which you can expand alpha cube plus beta cube. Okay, let me show it with the black color here. Alpha cube plus beta cube, you can expand it in two ways. First one is alpha plus beta whole bracket, alpha square minus alpha beta plus beta square. Or the other one is alpha cube, alpha plus beta whole cube minus thrice alpha beta, alpha plus beta. Okay, which one can we use? Let's say I use this one. You know the value of alpha plus beta, right? You know the value of alpha beta. But we don't know what is the value of alpha square plus beta square. We don't know that value. So this is not a very convenient formula to use here. So then, what are we going to use? We are going to use this. We know the value of alpha plus beta. We know alpha beta. And we also know alpha plus beta. We have already found out as minus p and q. Okay, so instead of putting alpha cube plus beta cube, we are going to replace it with this formula, right? Okay, so let's change the numerator. We're putting alpha plus beta whole cube minus 3 alpha beta, alpha plus beta divided by alpha beta. Let's see if we have all the needed, all the required values for all the terms. Alpha plus beta whole cube, alpha plus beta we already have. Just have to cube it. Alpha beta we have it here. Alpha plus beta we already have it here. And the denominator alpha beta we all have. We have all the values of all the terms. So alpha plus beta, we are going to put it as minus p whole cube minus 3 alpha beta. The value of alpha beta is q into alpha plus beta is again minus p divided by alpha beta. It is again q. Okay, you just work out the multiplication of the signs and open the brackets. That's it. So minus p whole cube, since there is a cube here, there is an odd number here. If you multiply minus p 3 times, minus minus is plus, plus minus is minus. So there will be a minus sign in front, minus p cube. So when you open the bracket, we are getting minus p cube. Multiply the minus and minus sign, we are getting plus. So we are getting plus 3. Let's put p first. 3pq divided by denominator is q. No need to change anything here. So we have calculated the value of this. First, we do a little bit of an addition, and then we do factorization. Not factorization, we expand this alpha cube plus beta cube into this formula right here. And then we put in the respective values. Very simple and easy. Likewise, the other Roman numbers 1, 3, 4, 6, you all try them. You will find that they are very easy ones. Okay, they are not difficult. You just have to find out alpha plus beta and alpha beta first. Then the question becomes very easy. Okay, let's move on to the next question. Question number 9. So look at the question first. Find the value of p such that 3px square minus 12x plus p equal to 0. It has equal roots. What's the condition given here? In order to calculate something, you just need to look out for what's our strategy in order to calculate the question. So first of all, let's find out what is given. According to the question, there is some keywords here. S equal roots. So there are roots, then there must be an equation. What is the equation? The equation is right here. It is a quadratic one, so it must have two roots, right? The two roots are equal. So if I take an equation like this, we take the roots to be alpha and beta. According to the equation here, alpha is equal to beta. That's what the equation is saying, if the roots are alpha and beta. So here, first of all, what is the equation? Here, the equation is 3px squared minus 12x plus b is equal to 0. First things first, you just need to find out a, b, and c first. What is a? A is the coefficient of x squared. There is a 3p in front of x squared. That's the coefficient, right? So a will be 3p. How much is b? B is what is in front of x. What is in front of x? There is a minus 12. So b will be minus 12. C will be how much? C will be the constant term. That will be b. What's the condition? It has equal roots. Okay, we have already learned what was the condition for equal roots, right? There is a condition for real roots. In that real roots condition, there is a condition, two conditions for when the roots will be real and equal, and when the roots will be real and unequal. What was the condition for equal roots? The condition for equal roots was that b squared minus 4ac, it should be 0. So you just put in the value here. Since the roots are equal, what condition will be satisfied? B squared minus 4ac is equal to 0. Okay, now put in the value. B will be minus 12 whole square. Minus 4a will be 3p. C will be p is equal to 0. Okay, here you can see that p is the variable, right? Others are constants. It's very easy to find out the variable then. So minus 12 square, it will be 12 square is 144. Minus minus, it will turn into plus. Minus 4 3s are 12. P into p, it will be p square is equal to 0. Okay, let's continue on the side. 144 is equal to 12p square. We do transposition. Okay, bring the 12 to the other side. 144 by 12 is equal to p square. You cancel it, you are going to get 12. If I want the value of p, then the square root will come into other side as square root. So you know that when you take the square to the other side, it turns into square root, but there should be a plus minus sign in the front. I have already explained it in the earlier video, right? So plus minus root over what is remaining on the left hand side, it's 12. Okay, 12 we can change it a little bit like this. 12 can be changed like this. 12 will be 2 into 2 into 3 when factorization, right? So this is 2 square into 3. If I write it in the form of square, if I pair the factors, then square root 12 will be square root of 2 square into 3. If you separate the square root, we are getting root 2 square into root 3. Cancel the square and root. We're getting what now? 2 root over 3. So square root of 12, you can change it slightly. So we are getting plus minus root over 12 is how much? 2 root over 3. That's it. We wanted the value of p. Now we have it, right? In order to calculate the value of p, what condition that we impose? Because the question says it has equal roots, we impose the condition that for equal roots, these conditions should satisfy. So b is here, 4ac, a and c, we just put in the value, and then we can calculate the value of p very easily. So these are very small marks question, okay? 1 mark, 2 mark questions. Okay, let's come to question number 14. Okay, here you have to prove something. Look at the question. You just brush up the concepts that we have done in the previous 3 videos. Okay, the derivations that we did, the condition for real and imaginary roots, the condition, the formula for addition of root and product of roots, so and so. So here, look at the question. If one root of the equation, here is an equation given here. It must have 2 roots, right? X square minus px plus q is equal to 0. If one root of the equation be twice the other. Okay, let's forget this part. One root of the equation be twice the other. What is the equation? The equation is right here. One root is twice the other. That's the given. Okay. What is given here according to the question? One root is twice the other. Okay, what do you have to do? You have to show that twice p square is equal to 9q. Where does the p and q came from? P and q came from the equation here. P is the coefficient, uh, p is what is in front of x, q is the constant term, right? So one root is twice the other. Let's say you have the roots as alpha and beta. So let's say the roots be alpha and beta. Let's say this one is bigger. If this one is bigger, then according to the equation, it should be twice the other, right? So alpha is, we are representing the is with equal to. Okay. Twice means you have to multiply by 2. Twice the other. What is the other root? The other root is beta. Let me repeat again. If the roots are alpha and beta, then according to the given, one root is twice the other. Let one root be the alpha, is equal to twice will be 2 times the other is beta. All right. So here, let's just put like this solution. What is the equation? The given equation is what? It's given like this. So from here, how much is A? A is 1, B is minus B, C is Q. So according to the equation, what condition should this equation satisfy? The root alpha is twice the root other one. What is alpha and beta? Alpha and beta be the roots. Okay, now let's come to addition and subtraction in order to arrive at this. Okay, what are the two roots? Alpha and beta. The two roots are alpha and beta, right? So first of all, you calculate the sum of the roots. Sum of the roots, you have to add alpha plus beta, right? What was the formula? Minus b by a. Okay, here we can do two replacement. Instead of alpha, we can write 2 beta, right? Alpha is twice beta. Get it? So here, instead of writing alpha, I can replace the alpha with 2 beta. So here, 2 beta plus beta is equal to minus b by a. How much is it? Minus b, minus of minus b, right? B is minus b. By a is how much? 1. So here, if you add 2 beta and beta, we are going to get 3 beta is equal to minus of minus b is plus b, p by 1. We can ignore the 1 in the denominator. 3 beta is equal to p. Okay, now calculate the product of the roots. So product of the roots, alpha into beta, what will it be? It will be c by a, right? Like we have done before. You can replace the alpha with 2 beta and c and a with the respective values as we have found out here. So alpha will be replaced with what? 2 beta into beta equal to c will be replaced with q, a will be replaced with 1. 2 beta into beta is how much? Twice beta square is equal to q by 1 is q. Can we find the value of beta? Yes, of course, yes. From this equation right here, we can find out the value of beta. There, if I find out the value of beta, 3 will go to the other side. It will become p by 3, right? So from here, let's continue. Beta is equal to p by 3. Okay, now let's put the value of p by 3 in this equation. Let's denote this by equation 1. Okay, so here, let me just write by equation 1. Now we are putting the value of beta is p by 3. 2 into beta is p by 3. So whole square is equal to q. Open the bracket. We just square the numerator and denominator. 2 p square, the numerator p n square, it will be p square. Denominator 3n square, it will be 9 is equal to q. What did the question wanted? Question wanted to show that 2p square is equal to 9q. So here, do cross multiplication. This part is the numerator, right? So you have to multiply. There is a 1 denominator, 2p square and 1 will be multiplied. 9 and q will be multiplied. So we are going to put 2p square is equal to 9 multiplied with q. We are getting 9q. So question wanted to show 2p square is equal to 9q. We have obtained 2p square is equal to 9q. Look at the steps very carefully. Where did we started? We started with the given that one root is twice the other. How do we put this? We take the roots to be alpha and beta, and we write alpha is equal to 2 beta. Okay, this is one of the question that is asked in board exams, your board exams once or twice, I believe. So it's an important question. Okay, note it down. Okay, next question. Question number 15. So this one will be slightly long. Okay, look. What does the question say? One root of the equation x squared plus bx plus q is equal to 0. Be the square of the other. Then so that pq plus q squared plus q is equal to thrice pq. Okay, look. First of all, if one root of the equation, what is the equation? This equation. Okay, forget this part. Okay, let me enclose it with a black rectangle. Okay, if I take alpha and beta, then this second root will be the square of the first one. No need to take beta then. We can take, instead of taking beta, if I take the first one is alpha, according to the question, the other root should be the square, right? So what will be the other root? The other will be alpha square. Why are we taking alpha square? Because the question say one root of the equation be the square of the other. Okay, so let's start solving this question. Solution. The given equation is what? X squared plus bx plus q is equal to 0. From here, we know that a is 1, b is p, c is q. Okay. By equation, what is the condition that is being imposed by the equation itself? By equation, the roots are, the roots be, first one, if we take it as alpha, the other one, don't take it as beta. Okay, we will take it as alpha square. That way, this is the square of the first root, right? Okay, now, like we have done in the previous question, you find out the sum of the roots and the product of the roots, and then we will do some uh, crossing over. So first of all, find out the sum of the roots. Sum of the roots. Okay, wait. Let's find out the product of the roots first. That way it will be easier. Product of the roots. Product of the roots are alpha and alpha square, right? So product of the roots will be alpha into alpha square. What will this be equal to? It will be equal to c by a. Alpha into alpha square is alpha cube. Instead of c, we are putting q by a is 1. So no need to put the denominator is 1, right? You can put by 1 here, but still denominator 1 is useless. Okay, let's denote this by equation number 1. What about the sum of the roots? Sum of the roots, the first root is alpha, second root is alpha square. This will be equal to minus b by a, right? Okay, let's do further calculation on the side. So here, for the left hand side, there is alpha and alpha on both of the term, right? So we can take out the alpha as common factor. Alpha 1 plus alpha is equal to minus b. Instead of b, we are putting minus. Instead of b, we are putting p. By 1, we can forget the denominator. No need to put the denominator 1 here. It's useless. Okay, so this is the sum. This is the product. The product is we obtain on the left hand side, we obtain alpha cube. What's the actual value? The actual value in terms of the coefficient is q. For the sum of the roots, we obtain minus p. Look what the question wants. Question wants us to show that p cube plus q square plus q equal to 3p cube. The hint to be taken here is there is a p cube here. How do we obtain p cube? Cube this. Okay, cube this. Cube this. If you cube here, then there will be a cube on this side also. Okay, so if I denote this by equation 2, then we can continue like this by cubing equation number 2. We're putting cube on all sides. Alpha cube 1 plus alpha whole cube equal to minus p whole cube. We remove the 1 from the denominator. Okay. Okay, now implies that alpha cube here, for this portion, use a plus b whole cube formula. What is the formula for a plus b whole cube? This will be a cube plus b cube plus thrice ab, a plus b. Instead of a, we are putting in 1. Instead of b, we are going to put alpha. So it will be 1 cube plus alpha cube plus thrice AB will be 3 into 1 into alpha 1 plus alpha, like this. So we can simplify it further. 1 cube will be 1. There is alpha cube here. 3 into 1 into alpha, we get 3 alpha, right? And then there is a 1 plus alpha. So that is the value we are going to get when we expand this portion, right? Okay, you put in the value exactly as I have wrote it. So what is the value here? 1 plus alpha cube plus 3 alpha, 1 plus alpha. Okay, since there is a first bracket here, we will replace the bracket, the parenthesis in the front with the second bracket. Then what will be on the right hand side? Minus p whole cube, we get minus p cube, isn't it? Minus, when you multiply 3 times, the minus will come in front. Okay, now it's time for us to put in the value. Can we put in the value? Do we have all the values? Yes, we do. Alpha cube. Look at the equation 1. Alpha cube is how much? Q. 1, let it be. Alpha cube, it will be Q. 3, okay, let it be. This whole portion, alpha 1 plus alpha, is this one, right? What is the value of this? It's minus p. So just put in the value. That's it. So alpha cube, we are putting q. 1 plus alpha cube. Alpha cube will be, again, we are putting it as q plus thrice. Alpha whole 1 plus alpha. Alpha whole 1 plus alpha. This value will be how much? Minus p. So put minus p. Again, we are putting second bracket. Is equal to minus p. Okay, let's do a little bit distributive property, apply distributive property, multiply all the terms, right? So q into 1, we are getting q. Q into q, we are getting q square. The plus and minus, when multiplied, will get minus sign, right? So there will be a minus 3p. 1 plus q minus 3p is equal to minus pq. Okay, do multiplication. Q plus q square minus thrice pq is equal to minus p. What did the question wants us to obtain? It wants us to obtain p cube plus q square plus q is equal to 3p. Do we have all the terms? Look, p cube, okay, we have here. Q square, we have here also. Q, we have here also. 3pq, we have here also. Only thing is the position for 3pq and minus pq, they are interchanged. Okay, do a little bit of transposition. Take this to the other side, bring this to this side. Minus p cube, here, this minus p cube, if I bring it here, it will turn into plus p cube, right? Okay, so bring it there. P cube plus, let's put q square first instead of q square, and then let's put q at last. Minus 3pq, we can take it to the other side. What will it become then? The minus will become plus. So we get E is equal to thrice p. Okay, so we have obtained what the question wants us to obtain. So just write hence shown. We have shown exactly what the question wanted. Okay. So here, where do we get the values for alpha cube and alpha 1 plus alpha? We get it from equation number 1 and equation number 2. So here you just mention putting what values did we put here? The values of alpha cube and alpha 1 plus alpha from where? From equation 1 and equation number 2. Okay, that's it. This is a very easy question. You just have to know that we took the roots as alpha and alpha squared. Okay, this question can be given 2 or 3 marks, mostly 3 marks actually. Okay, now let's do the last question from your textbook, exercise 5.1. This is another very important question that has already been asked in your board exam. So here, if the sum of the roots of the equation, an equation is given like this, is 0, prove that product of the roots is this, minus half alpha square plus beta square. Okay, does this look like a quadratic equation? It's a quadratic equation, all right. But a quadratic equation is supposed to look like this: ax squared plus bx plus c is equal to 0. It should have a quadratic term, it should have a linear term, and it should have a constant term, which none of them is here. So we will do a little bit of calculation. We will add the left hand side. We will do cross multiplication, and then we will try to put this equation in the form of ax squared plus bx plus c is equal to 0 first. What is the equation saying? If the sum of the roots, forget the equation, okay? If the sum of the roots of the equation is 0, that's the given condition. You have to prove this part. Sum of the roots is 0. That means if I take the roots as alpha plus beta, then it will be 0. Alpha plus beta, what is the value? Minus b by a, it will be 0. Okay, if it is 0, you have to prove that the product of the roots is this value right here. Okay, so in order to find out the sum of the roots, we need what? We need minus b and a. What is b? B is the coefficient of x, which we don't see here. A is the coefficient of x squared, we don't see here. What is the first need? We need to put this equation as ax squared plus bx plus c is equal to 0. That's our first priority, right? So solution, what's the equation given? 1 by x plus a plus 1 by x plus b is equal to c. Add these two terms, multiply the denominator and then cross multiply. So multiply the denominator, we are putting x plus a whole bracket, x plus b whole bracket. Cross multiply, x plus a multiply with 1, we are going to get x plus a, plus sign in between, x plus b multiply with 1, that will be x plus b is equal to c. Okay, let's open the bracket in the numerator and then denominator. Denominator, we have to multiply these two, right? Multiply x and x, we get x squared, plus x and b, we get bx, plus a and x, we get ax. Last one, a and b, we get ab. Okay, so denominator, we are getting like this: x squared plus bx plus ax plus ab. Numerator, there is nothing to do there. Just open the bracket. There is a plus sign in front, so nothing will change. X plus a plus x plus b is equal to c. You know that I can add these two terms. X plus x is 2x. These two are constant. I can put them separately. What about the denominator? Denominator x squared, let it be. There is a only quadratic term here. Bx and ax, I can take the x common from both of them. That way, there is a b remaining and then a remaining, right? From here, b is remaining, from here, a is remaining. Okay, when you take factorization, when you take common factor, when you put x in front or x in the x behind or in the front, it doesn't matter, okay? It's the same thing. Both of them, it still indicates multiplication. So numerator, x plus x, we're getting twice x plus a plus b by x squared plus, from these two we are taking out x common factor. What is remaining? B plus ax plus ab is equal to c. Okay, cross multiplication. We still haven't got ax squared plus bx plus c, that form of equation. We haven't got that. Cross multiplication, there is a one denominator, right? So multiply this and this. So left hand side, 2x plus a plus b, it still remains. Right hand side, do multiplication, cross multiply. So c and x square will multiply. C will multiply with this whole thing. Okay, just put it as it is. X square plus, I'm changing the b plus a into a plus b. Okay, here it was b plus a, I'm putting a plus b here. It's the same thing because there is a plus sign in between. So open this bracket. C and x square, cx square. C and a, ac. C and B, BC. C and AB, it will be ABC, right? Okay. So here, okay, there is a little bit of a mistake here. It should be 1 by C. Okay, here it's 1 by C. So here this calculation, when you cross multiply, you are going to multiply C and this, x square and this denominator and this. So when you multiply 2x plus a plus b and c, we're getting like this. So open the bracket, we're getting 2cx plus ac plus bc is equal to x square plus a plus b whole x plus 8. Look, we wanted ax square plus bx plus c. The x square term, leave it. There is only one of it. The term having x. Which term has x here? This term has x. This term has x also. You have to combine the both of them. Then there is the constant term here. Constant term is which one? Constant term will be AC and BC. They don't have any x attached to them. Okay. We will take everything this side to this side in order to combine the terms. Okay. So let me start x square plus a plus b whole bracket x plus ab. This is brought on the other side. All the signs will be changed into minus, right? So we will have minus twice cx minus ac minus bc equal to 0. These two terms we can combine, right? So x square plus, between these two terms, what can be taken as common factor? X can be taken as common factor. A plus b is remaining here. Minus 2c will be remaining from here. So a plus b is remaining from the first, minus 2c from the next, and there is an x outside. Remember, we have taken out this term and this term. What is remaining then? ab, ac, and bc. Let's put it behind. Plus ab minus ac minus bc equal to 0. Okay, what is the constant term part? This is the constant term part. So let's put them inside bracket. Okay, do we have the equation in the form of ax square plus bx plus c? Obviously, here look, ax square. What is a here? A is 1. Bx, bx. What is b? Instead of b, we have this whole term. Instead of c, we have this whole term. All right. So here, this equation, it has been transformed into this equation. Okay. In the exam, you have to complete until this and then follow the calculation afterwards. Okay. But because of lack of space, I'm erasing this portion right here. So here, instead of writing this equation, we are replacing it with this equation. So here, this is x square plus a plus b minus 2x, b minus 2cx plus ab minus ac minus bc is equal to 0. Okay, now, what does the question say? What does the question want us to do? Question wants us to prove that product of the roots is this value. That means alpha into beta is this value right here. Since we have a, b, c already, okay, so let's consider the coefficient b. Actually, from earlier, we denote a, b, and c as the coefficients of x square, x, and constant term, right? But a, b, c is already present here. So let's denote the coefficient is a prime, b prime, and c prime. So say here, let a prime, b prime, and c prime be the coefficients of x square, x, and c prime is the constant term, right? So write it off. So c prime is the constant term. Okay, now what is a prime? From the equation right here, it's the coefficient of x square. X square has no coefficient, so the value will be 1 now. What about b prime? The coefficient of x, this whole thing, a plus b minus 2c, a plus b minus 2c. What about the constant term? Constant term is ab minus ac minus BC. Okay, what is the equation saying? Let's read it. Sum of the roots of the equation. We don't write this equation anymore. We change it into this. Sum of the roots of the equation is 0. Let's say the roots are alpha and beta. So here, let alpha and beta be the two roots. So according to the question, what do we have? Alpha plus beta is equal to 0. How do we find out alpha plus beta? Alpha plus beta, we find it out by using the formula of minus b by a, right? In this case, it will be minus b prime by a prime. So you replace the left hand side, minus b prime by a prime, that is equal to 0. Put in the values now. Minus b prime, it will be minus a plus b minus 2c by a prime is 1, right? Is equal to 0. I can lose the minus. I can lose the 1. What is remaining then? A plus b minus 2c. So we are remaining with a plus b minus 2c is equal to 0. So we are having, take the 2c to the other side. A plus b is equal to twice c. From here, find out c. C is equal to, take the 2 to the other side, we will have a plus b divided by 2, right? 2, when it comes to the other side, it will be divided, isn't it? No need to write divided by 2. Okay, just let's just write half or leave it as it is. Okay, now we have done the part for addition. From the addition, from the equation of addition, okay, this is actually an equation according to the question, right? Sum of the roots is 0. So from this equation right here, we obtain that C is equal to A plus B by 2. Question wants what? Question wants us to prove that product of the roots is this value. How do we find out the product of the roots? Alpha into beta, we found it out by C by A, right? Okay, let me rub off all of this. Okay, so product of the roots, let's come back to this side. Let's come back to this side, okay? Continuation from here. Now product of the roots. Product of the roots will be alpha into beta. What is this equal to? It is equal to C by. We have to calculate the product of the roots. Okay, and then obtain this value right here. What is C? C is, as you can remember, just look it up. This part, AB minus AC minus BC. That's why I left it during erasing. So instead of C, we are putting AB. It's C prime and A prime. I'm sorry. AB minus AC minus BC. Okay. Denominator, how much is A prime? A prime is 1. So here, look at these two terms. Between these two terms, I can take out the C as common factor, right? Because here in the product of the roots, there is no C visible. So we want to remove the C. How do we remove the C? We first take out common factor, and then we can put in the value from here. So we have got AB minus, from the last two terms, we are taking out C common factor. A plus B is remaining. You know where this plus is coming from, right? If I take minus as common factor, the minus will change into plus. So AB minus, instead of C, from this here, let's put that as equation number 1. You put the value of C from equation 1. So we are putting A plus B by 2, and there is an A plus B already. This part is coming from here. This part is already there. Since these two are the same, okay, since these two are the same, I can write A plus B whole square, right? So AB minus A plus B whole square by 2. If I combine the denominator, we will have twice AB minus A plus B whole square. Okay, now look, this portion, twice AB minus A plus B whole square. Let's calculate it on the side. Okay, I'm rubbing this off. So twice AB minus A plus B whole square. What do we get? 2AB minus, open the bracket, A plus B whole square is A square plus B square plus twice AB, right? Open it. So when you open this, what we are going to get is twice AB minus A square plus B square. No, minus b square minus twice ab. These two can be cancelled out, right? So the remaining term is minus a square minus b square. If I take minus common factor, a square minus b square, there is a plus sign. If I take minus as common in front. So here, look, this portion, the portion here in the numerator, if I expand it, we are getting minus a square plus b square. So replace it here. Instead of writing this portion, this is the short form. So replace this with this. What do we have? Minus a square plus b square divided by 2. This form, I can write exactly like this, right? The divided by 2, I can change it into half, isn't it? So we will have half minus sign a square plus b square. Okay, look, we find out the product of the roots. Finally, what do we get? We get minus half a square plus b square. Okay, remember this is a little bit long. It may even be given 5 marks. This question is a little bit long. First of all, since this is not a quadratic equation form, this is not the exact form of the quadratic equation, we need to change it first. And then we had a condition given by the question, sum of the roots is 0. And then from here, we find out the product of the roots. We find out the product of the roots, and what did we replace? Instead of the value of c, we replace it as a plus b by 2 from the equation number 1. So here, just write by equation 1, c is equal to a plus b by 2. That's why we are putting the value of c. And then finally, we are able to obtain this minus half a square plus b square. Okay, that's it for today. We have finished your exercise 5.1. I just picked up the very important questions that is being asked in your, that has already been asked, has already asked on your board exams. Okay, there is a remaining exercise, and then we will do a little bit of a word problems. The very important ones, we will choose it from your exercise 5.2. The previously asked questions, the very important ones that I think may come in the coming years. We will do that from the next video. Okay, that's it for today. Goodbye.